Okay, so we previously looked at exponentials, exponents, and so now we're going to be looking at exponential functions. So an exponential function is where the variable is in the exponent. And we're going to have two occurrences. So I could have f of x is equal to 3 to the x, where this a is some constant value. This is a little bit different than if I have x to the third. This is a cubic. This is a polynomial function. Now, I'm making the base the number and the exponent the variable. We can have any value for a base. Now there is also this is e, this is base e. This is a natural base. This is Euler's number. It is important to know that e is not a variable. So a is some constant, x is a variable. But e is a specific value. It is a number. It is the same type of situation as pi, where pi is going to be 3.14 for what you're using it for, whereas e is always going to be about 2.717 or so on. You need to make sure that you understand that e is just some number. And it's going to follow all the same properties just as everything else. All right, so let's take a look at some things here. So take a look at this. And so what you might want to do is try plugging this into your graphing calculator. I'm going to show you the table, but we can think about what the graph looks like. So we're going to graph y is equal to 2 to the x. And before we do that, what do you think it's going to look like? Well, let's take a look at the table. These are some x values, and these are the corresponding y values. So if I have my x and y axis, a little crooked there, there's -1. -1 is about 0.5 for y. 0 is at 1. When x is 1, I get y is 2, and then 4, and then 8. So look at how this is going up. Up and up and up and up. What's happening with each step? What's happening to each y value? I go from a half to 1 to 2 to 4 to 8 to 16 to 32. For comparison's sake, let's look at y is equal to 3 to the x. I go from a third to 1 to 3 to 9 to 27 to 81 to 243. What's happening? Well, here in this 2 to the x power, I'm multiplying each y value by 2 each time. I'm doubling it. Down here, I'm multiplying each y value by 3 each time. So this base is really what we're multiplying by. We're multiplying each preceding value by this. When x is 1, I get 3. When x is 2, I get 3 squared. I'm multiplying the previous value by this base 3. What about when I have this? This is 2 times 2 to the x. Now please know, this is not 4 to the x. I have to follow my order of operations. My order of operations says I must use parentheses and exponents before I can multiply. So if you graph 4 to the x, it's going to look different. In fact, if you're ever not sure, you can graph and compare the two. If they're not the same, then you can't multiply them. All right, so let's take a look at this. So a little bit different. I get 1, 2, 4, 8, 16, 32, 64. Yet again, we can see this doubling. We can see I'm multiplying each preceding value by y. But that's because of by 2. But that's because of the base, not this 2 in front. If I have 2 times 3 to the x, notice again, I'm multiplying each preceding value by 3. Not 2. So where does this 2 come into play? Well, look at y is equal to 3 to the x. When x was 3, y was 27. Now 2 times 3 to the x, When x is 3, y is 54. So here, this is multiplying the original value. So this is almost like when we had parent functions. That is going to be the scale factor. We're going to multiply the y value by that amount. And that's how that changes. What about with negative x values? Well, just like your exponent properties, these are going to decrease. So these are decimals, but hopefully we can recognize the fractions. This is 1, this is 1/2, this is 1/4, this is 1/8, this is 1/16, and this is 1/32. These are now doubling, not in the numerator, but in the denominator. And same when we have 3 to the negative x. We are tripling each denominator. That's 1/3, that's 1/9, that's 1/27, that's 1/81, and that's 1/243. So we are tripling, we are multiplying by 3 each denominator because the exponent is negative. And so that's really all we're doing for this first section. It's not a whole lot of computational stuff. We're just looking at some of our exponent rules and applying them to graphs. How are the graphs going to change? How are the y values going to change depending on our function, depending on the exponential that's actually occurring?